everybody, and welcome back to another video. In this video, I will be covering Riemann sums from AP Calculus BC and AB. Now, in this question, we are given the function f of x is equal to x squared, and we are trying to find an approximate value for the integral from 0 to 3 of f of x with respect to x using a right-hand Riemann sum with a step size of 1/2. Now, we have a separate question, which I will call part B, which is this an over or an under approximation? And we will not be finding this exact value, even though it is incredibly easy to do. We will be using the graph to interpret this, because on the AP exam, you may be given a question like this with a function that you cannot actually write out like that. So you might be given a function which is like e to the sine of x, which you cannot integrate properly. Now, to begin, we will be drawing a graph of this function from 0 to 3. So as you can see, this is our axes, this is y, this is x. Let's label this point right here as 3, and this is 0. Then we go 1/2, then 1, then 3/2, then 2, then 2.5, then 3. So these are our points, and then we are going to draw in our approximate function, which we know that it looks like this. Just imagine that goes right there instead. Ignore that. So this is our function. So it is concave up through the interval, which will help us with this part B. So to begin, let's look at what this is asking. We are approximating the area under the curve of x squared, and using a right-hand Riemann sum. So what that means is we are looking at all of these boxes and adding up their area. So we have a step size of 1/2 for each of these. So each of these boxes have a width of 1/2. And if you look, this box has a height of f of 1/2. And then this has a height of f of 1. This one has a height of f of 1.5. This block right here has a height of f of 2. And it keeps on going. This one is f of 2.5. And this is f of 3. Now we are taking the sum of all these areas of the rectangles. So this is equal to our step size, which is 1/2. Times all of these terms. So I'm just going to bring the 1/2 on the outside. So that way I don't have to write it over and over again. So this is going to be 1/2 times f of 1/2. And if you remember, f of x is just x squared. So we are just going to be squaring all of these values. So this is 1/2 times 1/2 squared plus 1 squared plus 1.5 squared plus 2 squared plus 2.5 squared plus 3 squared. And this is our right-hand sum. So when you plug this into a calculator, you get that this is equal to 11.375. And this is our answer for the first part. This is our value for our right-hand Riemann sum, which you can see by this right here. Now, let's do part B. Is this an over or an under approximation? Now, since when you look at our graph, you can see that it is concave up, you could see that this area is the area that actually represents this integral. This area right here under the curve. So, look at these triangles. Each one of these triangles is adding to the area. However, it is not actually in the area itself. So, these are extra areas, so that would mean that 11.375 is an over approximation. So this is our answer for part B. Now, if you want to know what this area actually is, you would have to do the integral of x squared dx, which is equal to, this is from 0 to 3, this is equal to x cubed over 3, evaluated from 0 to 3. So the 0 is just going to be, this is just going to be minus 0. And this is going to be 27 over 3, which is just equal to 9. So this is our actual integral value. And as you can see, this is correct because 11.37 is more than 9. So our right-hand Riemann sum would be an over approximation. So this is what you can expect to see for sure on at least one of your FRQs for AP Calculus, AB, and BC. So I hope you all enjoyed this video, and thank you for watching.